student, in today's class we are going to learn some more concepts in discrete mathematics. The earlier class we had learnt about binary operation. The word binary represents 2. So the operation performed in 2 elements we call binary. Now proceeding with that, we are going to learn some of the properties which we can check in a particular set under the operation star. Star can be addition, subtraction, multiplication, division, or even multiply and divide by 2. Add and then subtract the product. So like this they will define in the question. So understand what the set is. In mathematics, what are the sets that we already know? The very first one I will say natural numbers. Natural numbers start with 1, 2, 3. The next idea, we will have Z. We call Z as integers. What do you mean by integers? It starts from 0 and the other side I have plus numbers, whereas the left side I have minus numbers. So I will say the set of integers contain 0, positive numbers and negative numbers. What should not come in Z? Decimals, fractions will not come in Z. The next idea, Q. What is Q? We call this as the set of rationals. What do you mean by the word rational? Something in the numerator and something in the denominator. 1 by 2, 3 by 4 plus root 16. 16 I know the square root, so it comes in Q. There are numbers for which I don't know the square root. It goes on and on like a non-recurring decimal. Root 2, root 3, root 5, such things. So, which set do I call for them? That is irrational numbers. So, Q when I say positive, negative, 0 and fractions. But when I come up to real numbers, this is containing all the rational numbers along with irrational numbers. What do you mean by the word irrational? The word irrational tells me square root of numbers which are non-recurring. So rationals, when they say, they will mention only Q. We must know what is Q. So Q is set of all fractions. When I say R, you must know what does not come in R. So R, I said the biggest number system. It contains all the positive, negative, 0, fraction, decimal, recurring decimal, non-recurring decimal. Then what only doesn't come in R? Remember, square root of negative numbers do not come in R. So if I want to say an element that is not in R, I can give an example, root of minus 4. Root of plus 4 is there, which is not there. Root of minus 4 is not there. So proceeding to exercise problems, we must know what these sets are. The next idea, the operation. If they tell you A star B is AB by 2, what does this mean? Multiply the 2 elements, divide by 2. For example, if my question is 7 into 8, what should I do? Multiply 7 into 8 by 2. Cancel. 28 is my answer. They can also give you like this way. A star B is A plus B minus AB. Find out what is 3 star 2 in this case. Wherever A comes, put 3. 3 plus 2 minus 3 into 2. My answer 5 minus 6, that is minus 1. So operation changes from question to question. You will be applying in the place of A, B, whatever number they give and your answer. This is not our usual addition multiplication. Depending on the question, star will differ. Now in this exercise, given star one operation and given any of the sets. Set they can give you like this also. A equal to ABC. They can very well give like this. So this is a finite set, I say. Not necessary infinite sets. So in the particular question, check what is the set and what is the operation they define. And then we will check whether these properties are holding in that. Now let us see what are these properties. Whenever A comma B belong to S, A star B also belong to S, I can say closure property is true. The word closure tells me the set is closed. So two elements are there. That answer also is inside the set. When I perform the operation, such a set we say closed set, and S is said to have closure property whenever A comma B belong to S, A star B is in S. Some of the laws that we can check. Commutative property. What is this? Already many of you know these things we have used in set theory. A star B, there we have done in union and intersection. Now we are going to do using star. A star B equals B star A for every AB in the set. Then I will declare star is commutative. The word commute, between the two, mutually we say exchange, interchange. A and B interchange, we say commutative law. Whenever they are equal, even if they interchange the place. The next property we say associative. Associative, when you call association, whenever three or more are there only, we call association. So associative property definitely needs three elements. For every A, B, C in the set S, A star B star C equals A star B star C. If I read like this, we will not understand because I have read it in the same way. So how should you read it? A star, pause after that. A star B star C, say together because it is inside the bracket, equals to A star B, say together, star C. So how do you read? A star B star C equals A star B star C. That is, we have changed only the bracket. Here I have put bracket for the second two, whereas here I have put the bracket for first two. Have I changed the order? No. Associative law, order is important. Here A, B, C. Here also A, B, C. Then what changes? Priority changes. I do B star C first. Then A star this answer. Same way the right hand side. I do A star B first. With that answer, I perform star C. So remember, order doesn't change, whereas the priority or the bracket changes. Here I do for second and third, whereas here I do for first and second. The next idea, we say existence of identity. What do you mean by this word identity? With any element of S, I perform the star operation with E. A star E or E star A. My answer should be A only. That element E has not altered A. That element E has not changed A. My answer is again A. Such element E we call identity. For example, if we are in addition, what is 0 plus 8? 0 plus 8 is 8. What is 8 plus 0? That is also 8 only. So we call 0 as the additive identity. And what do you mean by multiplicative identity? 1 into 8. My answer is 8. 8 into 1, my answer is 8. So, 1 if I multiply with any number, that number only comes. 1 when multiplied with a number does not change the number. that number is the same even after multiplying with 1. So the number is not altered. It is the same. This is what we say here. A star E or E star A gives us only A. That E we call identity. So here 1 is the multiplicative identity and 0 is the additive identity. In the same way, whenever I am telling identity, I should know the inverse also. What do you mean by the word inverse? For 8, if I multiply with 1 by 8, I will get identity. So, in multiplication, for 8, 1 by 8 is the inverse. For 1 by 8, 8 is the inverse. Identity tells that number comes the same. Inverse tells when I multiply with the inverse, identity should come as my answer. So how do you define it? A power minus 1. Don't read A power minus 1. You read it as A inverse or inverse of A. And we say inverse of A exists if A star A inverse equals A inverse star A equals E, where E is the identity element. We call A inverse as the inverse of A. And this we will say only if it exists for all the elements in S. Now tell me what will be the additive inverse. 4 plus 8. What should I add to get the additive identity? 0. 8 plus what gives you 0? 8 plus minus 8 gives you 0. So we will say for plus 8, minus 8 is the additive inverse. For minus 8, plus 8 is the additive inverse. Like this. For any other operation star, we will find out the inverse depending on the question. To prove that identity is unique, in a particular set, say yes, there is an operation star is defined. Can the set have too many identities? No. A particular set and a particular operation should have only one identity element. We are going to prove it. Take, for example, E1 be the identity and E2 be the element. So we consider E1 to be the identity and E2 to be the element. What is identity law actually? If I perform the star, A star E or E star A should give me only A. The element should come in the RHS. So here what will come? E1 star E2 or E2 star E1 should give me the element. In this case, what is the element? E2. So my RHS is E2, call it as number 1. Take the other way. Now, E1 is the element and E2 is the identity. E1 is the element and E2 is the identity. Now what will come? E1 star E2 or E2 star E1 should give me the element. In this case, what is the element? E1. Call this as number 2. Compare 1 and 2. Here also E1 star E2, here also. Here also E2 star E1, here also. So when LHS is same, RHS should be the same. So we will say 1, 2 imply E1 equal to E2 and therefore identity in a particular set for a particular operation is unique. So remember, you cannot have too many identities in a particular problem. So for a problem, that is for a set under a fixed operation, identity is unique. Here we have shown, if possible, we took two identities and we have come to the conclusion both must be equal. To prove that inverse is unique, in a set S under an operation star, we know if A inverse is the inverse of A star A inverse or A inverse star A is E. Let us assume, if possible, let there be two inverses for A. A1 is the inverse. A star A1 or A1 star A is E. Suppose A2 is the inverse. A star A2 or A2 star A is also E. My condition is to show A1 and A2 are equal. How am I to show that? Let me start A1. I can write A1 is A1 star E. Can I write it? Yes. E is an identity element. An element with E should give me the element only. The next step, instead of E, I can write from here. How shall I write E? E can be written as A star A2. Can I write it? A star A2 is E. The next step, change the bracket. Why? It is a set where star is an operation. I can use associative law. A1 star A star A2. This is equal to. So I have just reversed the bracket. A1 star A. What is my answer from here? E. So what is E star A2? E with any element gives me only A2. I started with A1, I ended with A2. So I will say A1 equal to A2. Inverse is unique. If possible, we have assumed two inverses. Start from the first inverse, which is written as A1 star E. E can be written from here, A2. Combine A1 and A. A1 and A is E from here. E star A2 should give me only A2. So I have concluded inverse is unique. So two major properties in sets that we are doing in exercise, that identity should be unique and inverse should be unique. Question number 5. Define an operation star on Q in such a way that A star B equals A plus B by 2. We need to check the 5 different properties. Closure. We know the formula. A comma B belongs to the set. Then A star B should belong to the set. Commutative. A star B equals to B star A. Associative. 3 elements we take in order. Change the bracket alone. Identity. A star E equals E star A equals A. Inverse. A star A inverse equals A inverse star A equals E. First, the question is in Q. Q is a set of rational numbers, that is fractions. It can be positive, negative and any type of fraction. Now, given A is in Q, B is in Q. So, whenever A and B are in Q, A plus B by 2 also belong to Q. Addition and division by 2 is obviously a fraction. Therefore, A star B belong to Q. Closure property is true. Commutative. What is A star B? Applying the formula, it is A plus B by 2. What is B star A? It is B plus A by 2. Are they equal? Yes. In numbers, addition is commutative. So, B plus A by 2, I can write A plus B by 2 and so A star B and B star A are equal, implies commutative property is true. Associative. We have taken 3 elements in order, changing only the bracket. Let us start LHS. A star B star C. What is A star B? It is A plus B by 2. In this problem, star implies add, divide by 2. Star C. What should I do? Star tells me add the 2. A plus B by 2 plus C by 2. Taking LCM, A plus B plus 2C by 2 together by 4. Similarly, I can do RHS. RHS is A star B star C. Keep A star. B star C tells me add, divide by 2. So B plus C by 2. A star B plus C by 2 tells me add. A plus B plus C by 2 divide by 2. Taking LCM, 2A plus B plus C by 2 together by 4. Are they equal? No. They are not equal. Here I have 2C whereas here I have 2A. Therefore, we will conclude star is not associative. The next heading, existence of identity. A star E. What is the formula? Add, divide by 2. A star E should give me A. So I will write this answer must be A. Cross multiplying A plus E equal to 2A. Or I will say E is 2A minus A, or else I get E equals A. If I take A, my answer is A. If I take B, my answer will be B. So E cannot be changing in a particular problem. So for every A belong to Q, if E is equal to A, the next time E will be equal to B for every B belong to Q. What does this tell me? E is not unique. In a particular problem, identity should be unique. So identity does not exist. The condition is not satisfied. Identity does not exist. Remember the idea. In a particular problem, only one identity should come. Identity should be unique. Whether I take A or B or C or anything, E should be the same. But in this problem, if I take A, E is A. If I take B, E is B. So E cannot be changing. So we will say identity does not exist. When identity does not exist, there is no question of inverse. Only if identity exists, I can proceed to the next step. So inverse also does not exist and hence the problem. Question number 6. Star defined on the set A, B, C is commutative. So fill the table. What do you mean by commutative law? A star B equals B star A. Check what is all given in the table. B star A is given. So B star A equals C implies A star B is C because it is commutative. B star C is given. B star C, the answer is A. Tells me C star B equals A because star is commutative. So we got what is AB, we got what is CB. Next AC we have to find out. Is A. Tells me A star C is also A. So we need to fill the 3 boxes which we have identified. Let us fill up the answer now. A star B. A star B, the answer is C. And C star B, the answer is A. And A star C, the answer is A. Thus, by using the idea of commutative law, where A star B equals B star A, we have filled the missing elements. Question number 7. Star is defined on a set A containing A, B, C, D, which is given in the table. Check whether it is commutative or associative. What do you mean by commutative law? We say A star B equals B star A. From the table, A star B, we must check like this way. First element check here, second element check here. A star B, the answer is C. B star A, B here, A here. What is the answer? B star A, I get D. Are they equal? No. So A star B not equal to B star A, and so star is not commutative. To check associative, associative law is A star B star C equals A star B star C. Again, find out LHS. A star. What is B star C? B here, C here. So what is my answer? B, C. The answer is B. B star C, the answer is B. Now I want A star B. A star B, the answer is C. So LHS I get C. Try with RHS now. First I will do A star B. A star B, the answer is C. Star C. A star B is C. Star C. C star C, the answer is A. Are they equal? No. So we will write A star B star C not equal to A star B star C, and therefore star is not associative.